Welcome to the first lecture on igneous rocks. Let's look at the three different types of rocks first. Igneous rock is a rock that comes from molten material, either magma or lava. Ig in igneous rock is a root word meaning fire, so these come from magma or lava. Metamorphic rocks come from rocks that have been changed due to pressure and or temperature changes. Meta and morph are two root words that mean change and form. The last type of rock is a sedimentary rock. These form from sediments, which are broken down rock fragments, and these are pushed together by compaction or cementation. What defines what type a rock is? In other words, what makes an igneous rock versus a metamorphic versus a sedimentary? Take a moment and think about it. The answer is how it formed. If it formed from magma or lava, that makes it an igneous rock. If it formed from sediments, that makes it a sedimentary rock. If it formed from an existing rock that had heat and pressure added to it, that would make it a metamorphic rock. So this lecture will take a closer look into igneous rocks. So igneous rocks form from molten rock that has been cooled. This could either be from magma or lava. The root word ig means fire. Remember that magma is molten rock that is underneath the Earth's surface, and lava is molten rock that is above the Earth's surface. These will give us two very different types of igneous rocks. The two types of igneous rocks are intrusive and extrusive. Intrusive form inside the Earth. Intrusive, inside. And extrusive form outside the Earth. So extrusive form in the exterior. Intrusive rocks form below the Earth's surface. This causes them to have very large mineral grains. Why do you think this is? Take a moment and think about it. Here's hint number one. Think about the temperature. How does the temperature inside the Earth compare to the temperature outside the Earth? The inside of the Earth is much hotter. So how would the hotter temperature affect how large the mineral grains would grow? This would give the magma a longer time to cool down. So when rocks are in liquid form, the atoms in the rocks can move around because they're not attached to each other. As they move around, they can find each other and bond. If you have more time for them to bond, they're going to grow bigger. My next question is, how do we know about the rocks that are below the Earth's surface, if they're below the Earth's surface? The soil and rocks that are above the intrusive rocks over time will erode away, exposing the intrusive rocks on the surface of the Earth. There are three types of intrusive rocks that we will talk about. The first one is granite, second one, diorite, and last, gabbro. These all have a very coarse-grained texture, which means they are very big and you can see them without using a microscope. Granite is a light-colored intrusive rocks, diorite is in the middle, and gabbro is a very dark-colored intrusive rock. Extrusive rocks are rocks that form above the surface of the Earth when lava cools down. These all have a small mineral grains. Why is that? Think about why intrusive rocks had large mineral grains. Extrusive rocks cool very quickly because they form outside the Earth's surface. Therefore, the atoms don't have time to find each other and bond, and grow big. Think of this analogy. Compare a 3-year-old versus a 30-year-old. The 30-year-old had more time to grow than the 3-year-old did. Therefore, the 30-year-old is bigger. Same thing with the rocks. The intrusive rocks had a longer time to grow, therefore they got bigger. Extrusive rocks do not have time to grow, so they do not get big. So extrusive rocks have a fine grain. This means when you look at a rock, it all looks about the same color. You can't see different colors. These are some of the common extrusive rocks. Rhyolite is a light-colored, andesite is gray, and basalt is black. Scoria and pumice both have what's called a vesicular texture. This means that there are holes in it, and they are very lightweight. Scoria is going to be dark color, and pumice will be light in color. Obsidian has a glassy texture. Obsidian is what Native Americans used to make their arrowheads out of. Obsidian forms when it is ejected out of the volcano into the air and cools extremely rapidly, so there is absolutely no mineral grains in obsidian, no crystal structure. Here are some vocabulary words that we'll be using to describe the rocks. Mafic, or also known as basaltic, are rocks that are very dark in color. They're typically very dense and very heavy because they have lots of iron and magnesium in them. The mineral composition for mafic rocks are typically pyroxene minerals. Olivine and hornblende are examples. The next type, felsic, also known as granitic, these are very light-colored minerals and have a relatively low density. These typically will have lots of silicon and oxygen. Minerals that are common in felsic rocks are orthoclase feldspar, plagioclase feldspar, quartz, biotite, and muscovite. Intermediate is a mixture of mafic and felsic minerals, so they will have a medium type color. These will also have a mixture of all of the mafic minerals and all of the felsic minerals. Okay, time for some practice. Take a look at rock number 1, and I would like you to identify the texture and the composition. First, let's look at the texture. Your choices for texture are coarse, fine, vesicular, or glassy. The answer is coarse. If you can see different colors in the mineral, that's going to be coarse grain. So I can see white, I can see black, and I can see pink. So I see different colors, therefore it's coarse. Next, tell me the composition. Your choices are basaltic, granitic, or intermediate. The answer is granitic, also known as felsic. The reason for this is because of the pink mineral. The general rule of thumb, if there's any pink in a mineral, it's going to be considered granitic or felsic. The pink that you're seeing is potassium feldspar, which is one of the minerals that we looked at. The white is the quartz, and the black is either hornblende or biotite mica. Next, take a look at rock number 2, and again, think about its texture and composition. The texture, again, your choices are coarse, fine, vesicular, or glassy. The answer is fine grain. For the most part, the whole rock looks like a solid color. It looks black. That will give you a fine grain texture. Next, let's look at the composition. Your choices are basaltic, granitic, or intermediate. This rock is basaltic, also known as mafic. The reasoning is because it's black. It's dark. Basaltic rocks are typically dark. Okay, let's do this again. Rock number 3. What's its texture? Your choices are coarse, fine, vesicular, or glassy. Your answer is vesicular because there's holes in it. Next, what is the composition? Basaltic, granitic, or intermediate? Your answer is basaltic, also known as mafic, because it's very dark. Now look at the last rock. What is its texture? Coarse, fine, vesicular, or glassy? Your answer is coarse because you can see different colors. I see white and I see black. Next, what's the composition? Basaltic, granitic, or intermediate? Your answer is intermediate. The reasoning is because there's about half the rock that's black and half the rock that's white. Therefore, it's intermediate. Half dark, half light. Now, when this magma doesn't reach the surface of the Earth, we get what's called igneous intrusions, which means the igneous has intruded on other rocks and got stuck. It solidified, meaning it turned into a solid, and we get certain structures. The first one is called a batholith. Batho is a root word meaning deep. Lith is a root word meaning rock. So this is a deep rock. This is the largest intrusion, about 100 kilometers squared. Next is a sill. Here the magma forced in between rock layers and is therefore horizontal. So the way I remember this, a windowsill is horizontal and sills are horizontal. Next is a dike. Here magma is forced up vertically through rock layers, so they're on an angle or vertical. These will cut through the rocks. The way I remember this is I think about spikes. I think of spikes standing up and dikes stand up. Next one is a laccolith. This is essentially like a sill, only much larger, and it pushes the rocks above it upward, creating a hill. Last is a stock. This is a vertical batholith that is much smaller than 100 kilometers squared. Next up on the igneous intrusions is a volcanic neck. Here, this is the inside of the volcano, in which the outside of the volcano is eroded away, and this sticks up out of the ground. A lava plateau is where lava flows out on the Earth's surface and creates a plateau, creates a raised area of the land. Next, we are going to look at a diagram. I think a picture's worth 1,000 words. So the batholith is at the bottom. It's very large. The vertical ones are our dikes. So these are all dikes. Horizontal ones will be sills. So these are horizontal, and they're usually in between the rock layers. Here is a pluton. This would be your volcanic neck. Here is your lava flow. So the lava comes out of the volcano and flows across the land, and that creates a little plateau. So that would be a lava plateau once it solidifies and hardens.